a worker, are you comfortable working in your current environment right now? What do you think about the air temperature? Is it too cold or is it too hot? Thermal comfort will be the key to your answer. Assalamualaikum and very good day to listeners. I, AMIRAH MAZLAN, will be presenting on my final year project titled A Study on Thermal Comfort Among Workers in UNM Health Center. Ladies and gentlemen, thermal comfort is an important factor that has a big impact on workers' performance, productivity, and overall well-being in different indoor settings. Thermal comfort is mainly affected by two factors, which is the first one is environmental parameter that consists of air temperature, air velocity, relative humidity, and mean radiant temperature. And the second one is on the individual's trait, which is their level of physical activity, their metabolism, as well as their clothing insulation. The health sector contributes significantly to society by providing necessary medical treatment. Generally acknowledged that health centers frequently have a continuous flow of patients and workers. Unlike other kinds of buildings, health center has a diverse population of occupants and including guests and regular users such as doctors, nurses, pharmacists, cleaners, and janitors. They are susceptible to thermal discomfort because of the amount of physical activity and interaction they engage on a daily basis. To ensure their thermal comfort, it is necessary to maintain their productivity, their job satisfaction, as well as their overall well-being. Health centers have their own environments that require a high level of safety and hygiene. Studies about workers' thermal comfort are less common because of the focus on patients' thermal comfort instead of the workers. Furthermore, studies on thermal comfort in health centers has primarily focused on steady state conditions, ignoring the nature of workers' activities that contribute to variations in thermal comfort. However, the thermal comfort of workers in health centers is equally important given that their activities, movement, and occupational requirements differ significantly from those who are typically on the office settings. There are three objectives in this study. The first one is to determine the environmental parameter, the second one is to assess the thermal comfort, and the third one is to correlate the thermal sensation vote with the predicted mean vote. The American Society of Heating, Refrigerating and Air Conditioning Engineers, ASHRAE, define thermal comfort as the condition of mind in which satisfaction is expressed with the thermal environment. It is a subjective perception that differs from individuals and is influenced by factors such as air temperature, air movement, and personal characteristics. Moreover, an environment must be neither not too cold or too hot to achieve thermal comfort. When individuals are thermally comfortable, they experience a sense of satisfaction which positively impact their overall satisfaction, emotion, productivity, and performance. To determine the environmental parameter, Ohm Delta Microclimate HD32.3 TC device was employed. There are three probes that has been used in this study, which is the first one is omnidirectional hot wire probe, the second one is globe temperature probe, and dry bulb temperature probe. Next, to assess the workers' thermal comfort, a questionnaire was distributed to the workers. The questionnaire was developed based on ISO 28802 and it has three parts. The first part, part A, which is on the personal information such as age, height, weight, gender, as well as occupations. Part B were on the list of clothing that was according to ISO 9920-2009. And part C was the evaluation of thermal comfort, thermal sensation vote, as well as thermal preference vote. For data analysis, Microsoft Excel was used to analyze the average data of environmental parameter using bar graph and scatter plot. Predicted mean vote was assessed by using Center for Built Environment CBE thermal comfort tool where the measured thermal parameters was digitally calculated. The average air temperature at receptionist hall, pharmacy and medical laboratory was 34.1 degrees C, 34.4 degrees C, and 34.2 degrees C respectively. DOSH 2010 established 23 degrees C to 26 degrees C as the permissible range for air temperature. On the other hand, ASHRAE guidelines recommended a range of 20 degrees C to 24 degrees C. Thus, the results showed that the value of air temperature at this location was acceptable based on the standards. The air velocity at 3 locations ranged from 0 to 0.04 meter per second. The receptionist hall and pharmacy have a mean of 0.03 meter per second. On the other hand, medical laboratory have a mean of 0.04 meter per second. The mean values in these locations were lower compared to the suggested acceptable range of air velocity that was 0.15 meter per second to 0.50 meter per second that was suggested by DOSH 2010 and 0.8 meter per second that was suggested by ASHRAE guidelines. The collected data on the relative humidity in these locations ranged from 45.6% to 54.8%. The relative humidity at receptionist hall, pharmacy and medical laboratory is within the acceptable range, which is 40% to 70% that was set by DOSH and ASHRAE standard. A total of 45 respondents were surveyed. As we can see in figure 3, 71.1% of them were female and 38.9% of them were male. Based on figure 4, the workers' average age was 46.7% of them being around 36 to 40 years old. In figure 5, the majority of the workers are nurses, which is 33.3%, followed by pharmacists, which is 70.8%, and receptionists, which is 11.1%, as well as laboratory assistant, which is 8.9%. The activities differed for each role. As we can see, the highest activity that was conducted at the health center was consulting patients, which is 31.1%. Most of the activities were handled by nurses, such as registering patients at receptionist hall and arranging, giving and checking medicine at pharmacies. Other activities were also handled by nurses, but at different locations at the health center, except for laboratory assistants that consist of normal workers. Figure 7 shows that most workers felt slightly cold with 50% votes in pharmacy. This is because health centers use centralized air conditioning systems that distribute the air evenly at various locations. On the other hand, at the receptionist hall, 50% of the workers felt slightly hot due to their active movement in the health center. Besides, most of the locations that they are working on are open concept space with different occupancy of individuals. In medical laboratory, 37.2% of the workers felt slightly cold due to the air temperature that are required to store the blood samples. The results of this study shows that individuals have different thermal sensations due to individual difference such as their gender, age, activities, clothing, as well as their metabolism. Figure 8 shows the correlation between TSV and PMV. The correlation is considered as positive but negligible correlation. As we can see, the votes are mostly at the slightly warm region, but according to the environmental data, the temperature is actually slightly cold. This is due to their activity, metabolism, clothing, occupancy, and type of the workstation that make the workers feel slightly warm. By analyzing the linear regression between TSV and operative temperature, as illustrated in figure 9, there is a positive relationship but not significant to TSV, meaning that the neutrality point for the workers in the health center is slightly cold. This depends on their metabolism and clothing insulation. Ladies and gentlemen, as a conclusion, the assessed location's environmental data is within the acceptable range except for air velocity. For thermal comfort assessment, there were areas of discomfort and suboptimal thermal conditions that has been reported by the workers. On the other hand, the correlation is considered as positive but negligible correlation. However, the association between TSV and PMV is not particularly strong or significant. As for recommendations, future studies on thermal comfort in Malaysian health centers should evaluate the effects of workload on the thermal comfort of the workers, considering factors such as irregular hours and long shifts. Additionally, investigating the advantages and difficulties of providing individual control over thermal comfort settings, such as personal fans and adjustable thermostats, can help to improve worker satisfaction, well-being, and productivity. That's all from me. Thank you.